All right, so now we're going to apply our sum to infinity formula. So here we've got 100 to 80 to 64. So it looks like my R value is 80 over 100, which is 4/5. 4/5 is less than 1, therefore sum to infinity exists. So now my sum to infinity is going to be u1 over 1 minus 4/5. So we've got 100 over 1/5 is going to give us 500 for our sum to infinity. This one, I hope that you know that 0.6 repeating is 2/3. But how can we find it using the idea of sum to infinity? Well, let's think about our decimal equivalent. That's 0.6 plus 0.06 plus 0.006, etc. So we've got a u1 of 0.6 and an r value of 0.1. So again, this is less than 1, so my sum to infinity exists. So my sum to infinity is going to be u1 over 1 minus r. So then I have 6/9, which is of course 2/3. So this is a really neat application, I think, of sum to infinity. All right, now we've got a geometric series. Sorry, this is our geometric sequence. We're going to turn it into the geometric series. So let's look at our terms. We've got a first term of 100, and then we would get positive 50, negative 25, etc. So even with our negative r value, that's okay, sum to infinity, because the absolute value of r is still less than 1. So we can find our sum to infinity, negative 100 over 1 minus, don't forget that your r value was negative, so negative 100 over 3/2, so that's positive, gives me negative 200 thirds. And there's some sum to infinity examples.